All right, good afternoon again. And it's absolutely a fascinating topic of going and a overall theme to go from a telco to a techco. And what better than open source as an enabler to open up new opportunities. Thank you very much for listening. I'm Arpit Joshipura. I head up networking edge IoT at the Linux Foundation. And what I'll cover today are three very important topics. A very short overview of Linux Foundation for those of you who are not familiar with us, but then give you enough reasons on what are the attributes of a true techco in telecom, and then give you some examples of some innovation that's already happened. All right. For those of you who are not familiar with the Linux Foundation, which I would be hard pressed to find, we are one of the largest nonprofits here, and our goal is to create shared technology and enable global collaboration. Companies, developers, users in pretty much space that is important to the world. And today, I'm only going to cover, telecommunications. But overall, we have over 1,000 projects in some of the most critical technologies of the world. So we have projects in verticals, many of the verticals, talking about telecom, automotive, finance, energy, etc., or technologies like blockchain or security or AI, etc. And we have projects in hardware and software, but most importantly, we have one of the largest ecosystem of developers globally that come together and solve common problems. And these are problems that are non-differentiated most of the times, where there are no competitive issues, but mostly it is to solve the software aspects of a stack that is generally common. And 70–80% of the code that we know today is non-differentiated. And that's why open source has become such a fantastic tool to speed up innovation. So with that background, let's start off on why open source in telecom and why these are the reasons for not just global adoption, but for going from a telco to a techco, right? You can't just do a PowerPoint and say, I'm now a tech company. There have to be good reasons to make that happen. And the reason, why here we, in Silicon Valley, and that's probably very early on, 4:30 a.m. But I just want to assure you that, we have taken the best practices of a technology company, a tech company, and we've applied it to 100+-year-old industries like telecom, like energy, like finance, like banking, etc. And these are the reasons. So let's go into the detail. First of all, for those of you who have not read this white paper, it's called Software Defined Vertical Industries. Please download it on our Linux Foundation website. It covers the industries that I just talked about and why open source has completely changed the way software gets done or the industries get transformed. And Linux Foundation is at the heart of it. So talking about networking or telecommunications specifically in this instance, the fundamental reason is it's an end user driven initiative. Not just from NFV and SDN, but all the way to cloud native, which started off about a couple of years ago, and moving forward to AI for network and network for AI. And the reason it's end user driven is top 8 of the 10 service providers are defining this paradigm shift. And they're running live in the production networks. Okay. So very important. It was jump started about 7 years ago by some of the larger carriers globally, and it has since then taken off significantly. So the first characteristic is end users have to be excited and participating if you want to jump from a traditional telecommunications organization to a full tech company. Okay. Now, that doesn't mean they have to keep coding, but they have to participate. That's number one. The second reason is tremendous amount of what I call shared R&D and TCO savings. So it's all about numbers. And we are focusing on common interoperable software that's non-differentiated. In telecommunications, it's almost 80% of the code. Load a box, load a switch, start, log, upgrade, downgrade. There's so much of this, orchestrate a policy, do a control loop, et cetera, et cetera. This is all common code, and it's non-differentiated. A vendor A and vendor B do not compete on that for business. And so that code, if you look at by the numbers, under what is called LF networking, which is kind of one of the largest directed fund or umbrella foundation or sub-foundations within the Linux Foundation, look at the speed and look at the amount of changes that happen with the amount of lines of code or technical contributors. And this is coming from global users, end users, vendors, system integrators, et cetera. The key here is it's shared R&D, operated under neutral governance and completely open policies. And this is why this has seen tremendous savings, because now you have the ideas of the world. So that's the second reason, and it's very important. The third reason is open source is more secure. So in a tech world, when there are more eyes on the software, it is extremely easy for the code to be secure. You just can't put in anything. Now, there are quantitative analysis and PhDs working on this, and they have proved that open source is more secure with papers and papers. I would point out two things that need to happen to show it. One is when entities like US government, and there's a white paper that has been written called Securing Open Source Software Ecosystem. It just came out this summer. Definitely download this, where they actually demand the telecommunication systems that they are basing their deployments on requiring open source. So how do you know it's more secure? You have dashboards, you have checklists, you have visibility. It's not just CVEs, it's well beyond CVEs, where you have to look at everything from code to software bill of material, and you actually get badges. And our open SSF directed fund actually allows you to implement a framework on how secure open source software is. So again, just because you are a Techco and just because you're opening things up doesn't mean you don't have policies, guidelines, and measurements that show that you're more secure. Okay, that's reason number 3. Reason number 4, which is kind of the most important for everybody, is the speed of innovation. It's rapid deployment, rapid bug fixes. Gone are the days where you take 18 months for a carrier to change and update a bug or a feature. Typically, oh, this doesn't work, or I need this feature. You go to a vendor comes in with the next release, prioritizes the feature. You test it internally, interoperability, and then you trial it and deploy it. 18-month life cycle. Now it's 2-week sprints, 4-week testing, typically quarterly releases. And this is learned from the best of the best cloud companies who participate in this open source ecosystem. And one of the biggest advantages is, by default, shared code is interoperable. And so from months of RFX, POCs, you are actually getting to very, very quick modern CI/CD tooling application, etc. And then LF networking also has an initiative called 5G Super Blueprints, which actually allow you to integrate multiple of these projects based on use cases in the open community that can be reproducible very, very quickly. So rapid deployment and rapid bug fixes is the hallmark of an open source system. And then finally, you can actually deploy it in vertical markets, and you just don't have to be a dumb pipe with just transport bits. So how do you do it? Well, you take these projects, which are on the bottom. And by the way, I'm going to get into details of these projects. You take it and you start integrating it, deploying it in three big markets: enterprise networking, service provider, which includes telecom and cloud service providers, and then specialized end users like governments and others. And then within enterprise, you prioritize various verticals and what they need, whether it's industrials, energy, commerce, et cetera, et cetera. And you can see that not just the core and the cloud, but the edge and the access, everything end to end has really picked up from a solution perspective for these kind of adoption. Now, keep in mind, open source plus proprietary software plus products and vendor solutions is what the right formula is. It's not all open source, but the bulk of it, which is the plumbing software, is open source. So with that said, let me go into some of the details of how we are envisioning the deployment and the build up of this Techcos. And by the way, today, most of the networks, the top networks, are using frameworks from the Linux Foundation networking software to build this framework. Okay. So this is a very important slide. I'm sure you're taking screenshots of this, but it is our left to right slide where, let me take a couple of minutes to explain it. The way we are structured is we have sub-foundations within the Linux Foundation that focus on specific areas of technology or areas of the network. Let me start off with the connectivity layer. So we host on the top the ORAN Alliance software community, which is one of the largest ORAN software communities. And I think you've heard from the earlier panelists on how RAN has become, is getting to an open source aspect. So we host that. We also host what's called Ether or SD-RAN as a community. And we just signed partnerships with OAI to allow for Blueprint integration. So you can see there's a center of gravity for us in terms of the Open RAN software that comes together for mobile access. You move down, you have sort of the last mile enhanced access for GPON. So this is disaggregated PON, passive optical network. So any access, and these are largest of the large carriers like Deutsche Telekom, Turk Telekom in production deployment. So we host a project called LF Broadband to support that. And then everything else, which is fixed wireless access, 60 gigahertz, rural connectivity, last mile, etc., is under the sub foundation called LF connectivity. And so you can see that these foundations are trying to solve the access issue, whether it's mobile, residential, enterprise, does not matter. Then you come in to the edge compute. And as I said, edge compute has taken off tremendously. There are two types of edge terminologies, and it's very important for the listeners to understand. You don't want to use terminologies like thin edge, thick edge, far edge, near edge. They're all relative. So our community under the sub foundation called LF Edge has defined a user edge, which is under the control of a user, and a service provider edge, which is under the control or as a shared service. And then there are multiple implementations of a user edge, whether it's microcontroller and constrained device or in a data center under the control of a user. So we have about 15 or so projects under LF Edge. And the goal of this sub-foundation is to unify the four markets that define edge computing, whether it's telecom, cloud, IoT, or enterprise. Very, very important. And they work in cohesion with the telecommunications networks. And then the most important open source initiatives are all in the core and the cloud side, which is on the right-hand side. And here you can see the entire stack that goes from a network operating system like a Sonic or a Dent, or new programming languages like P4, up to the data plane with FDIO or DPDK, or even eBPF, going into Kubernetes, Nepio, controllers like Open Daylight, orchestration engines like ONAP, and then moving into the application layer on top, whether it's a reference implementation like Silva, which is one of very important LF Europe projects that has come up, and is built off the projects under LF networking, but specifically putting out LF Europe's vision, led by Orange and some of the others, as well as projects like Camara that define API for monetizing this networks, again, initiated by Deutsche Telekom, but tremendous amount of global participation. So you can see the entire stack, and I know I took a little bit more time, but this is very important before I double click into some of the advancements that has gone in. Now, keep in mind, open source cannot operate in isolation. It operates in conjunction with other open source foundations, and most importantly, standards, specifications, and alliances and consortiums. So Linux Foundation networking set up collaborations and what we call MOUs with pretty much all of the bodies, and implementations of these standards have been put into open source so that there is no fragmentation of the telecommunications market. And it has increased tremendously over the last couple of years as the community comes together and realizes that if a standard exists, we code it as a community. If there is no standard, the community codes it, becomes the de facto standard that gets upstreamed into an ETSI or a GSMA or a 3GPP or anything else. So let me give you an example of one of the hottest projects called Nepio. And Nepio is part of LF networking, and its intention is to allow the simplicity of the cloud to be extended to a telco, which creates this whole Techco environment. And it is delivering a cloud native intent automation. So if you have what's called CNFs, and I remember announcing the term CNF at one of the Mobile World Congresses in pre-COVID, and now CNF has just caught on. Really excited about that. Nepio allows for the CNF automation here. It's a lightweight Kubernetes add-on bridge that bridges that stack between an enterprise telco and a cloud. Very, very important. So how does it benefit? Benefits the cloud service provider because it's just Kubernetes and common CRDs, common plugins. Service providers easily can adopt and extend the open automation model for CNF. So if there is a CNF, whether it's a packet core or a RAN or whatever, you can easily port it and automate it in a cloud native environment just by giving intents. The network function vendors, right? The workload application players, easy for them because they don't have to vertically integrate it all the way down to infrastructure. And it's all based on open standards. So you get the best world. And that's what drives the innovation really quick. So I'll just take a minute to go a little bit deeper into this, where you can see that it's a simplified cloud native network automation coming from end-to-end service orchestration, as well as end-to-end slice management projects like ONAP, which is one of the hottest projects deployed here in US, in China, and in other places in Europe. That gives you an open API interface into the network automation layer, and then right into the cloud infrastructure layer. And we are now on release 3, lots of great use cases. If you're not already participated, go to Nepio and look at what the project has done so far. Okay, huge participation globally on Nepio. And as I said, based on standards, come in through a classic API, ONAP service orchestration, go in, and then the orange is really Nepio. And as you know, Kubernetes is in one of our sister organizations called CNCF, and it's fundamental to how Nefio gets built for the cloud infrastructures. Okay. We have another initiative called CNTI, or Cloud Native Telco Initiatives. So what it is it's a way of automating and testing a CNF, and now the entire test framework is part of LF networking. And if you are a network function vendor and you want to get tested and certified so that operators can deploy very, very quickly, participate in this initiative. And we've seen very good progress that some of the new next generation of CNF vendors have utilized this infrastructure in a community-led initiative. And again, all of these things are just for one simple reason, which is opening up the telecommunications network to becoming technology aware, open source, and allowing for speed of innovation. And what the community is focusing on now is what I call domain-specific AI. So this was launched last year, and what the community is doing is focusing on what matters. Okay, so it's not about this generic LLMs and things that everybody talks about, but it is just what's relevant to the telecommunications. Let me explain this and how it's set up. So the purple in the middle is all the common things, whether it's common open AI models or compute elements, governance, processing, data sharing, etc. That's done by something called LFAI and data, which is one of our system sub-foundations. But everything on the top and the bottom, starting with the bottom, is all done by LF networking. So this is what I call domain-specific AI in telecommunications. Network infrastructure has a rich set of open source projects that I just gave examples of. Plus, it has a huge amount of data. So LF networking is now providing data sets that telecommunications models can be trained on. And if you know intent-based network, we're almost there. We have control loops, but we don't learn from it. And that last step, which is learning from the data and learning from the network behavior, and then just applying policies, that's today. But instead of applying policies, whether it's manual or automatic, we're now allowing the next phase of the network, which is network for AI, and AI for network. Now, some of the largest of the large carriers are donating some of these data sets to get trained on under LF networking. So if you're not a member of LFN, do join, send me a quick tap on LinkedIn or others, and we'll get you connected. But that, along with domain-specific use cases and domain-specific models, is the pillar of what this telecommunications network should be doing. And by the way, this framework we have pushed across the energy domain and some of the other domains as well, because at the end of the day, you can only do so much of asking ChatGPT, right? That's not where the money is, and that's not where the problems are for the telecommunications domain. Okay. Now, I can go into details and details, but there's very high quality data. There's trust, there's cost, there's research models, there's context on the data sets coming from all the layers. There's a huge set of value, and open source is the only way to do this. There's not a single organization in the world that can do all these for domain-specific AI. So we're really excited and happy to kind of allow the community to do this level of investigation. So with that said, I think the community keeps going on. We're now focusing heavily on the RAN and then AI for RAN, because there is a lot of intelligence that is getting pushed into the RAN as Open RAN opens up. There are edge compute environments that come in. So for example, in the sister foundation that I talked about called LF Edge, there is tremendous integration with the core. There are projects like InstantX that have been donated by Vodafone, for example, that allow for instantaneous exchange of data between any of the vehicles or drones to an edge cloud. And there are projects like InfiniEdge AI that take large language models and large AI things and then optimize it for edge. There are projects like Edge Lake that keep the data in the edge compute and prevent it from growing to a public cloud. Again, I'm not going to go through all of these projects, but the edge is an extension of what I just mentioned to make a full end-to-end Techco from a solutions perspective. Okay. So with that said, I'm going to just say, if you're not a member and if you're not participating, whether you're doing code, whether you're an end user, whether you're a vendor, whether you are trying to put things in production, please participate. This is the revolution of the decade that has taken the telecommunications from being just a telco to being a Techco. And again, for more information, lfnetworking.org, lfedge.org, etc. And with that, I am going to stop and hand it back or take questions or any, I don't know how things work here.
We have got a couple of questions for you.
Go for it.
How is responsibility pinned for any critical failures in an Open RAN? Oh, sorry, I think that's the last one for the Open RAN scenario. I think that's the last one. My question would be to you, what do you think the next great big area is in telecoms for open source, Arpit?
The next big area, I think I mentioned it briefly. It's really two aspects, right? So as the cloud and the core have already gone down this journey of open source, edge is next. And so that has already happened or is happening, I should say. The next big thing that's happening is opening up the RAN or the radio access network. Now, O-RAN Alliance defines an architecture which has about 7 blocks, give or take one or few. But if people are familiar with the RAN architecture, there are about 7 pieces of the puzzle. 4 of them are already open, right? So the SMO currently can be built from components of ONAP project, for example. NFVIs, like the cloud architecture is open, etc. The XApps, the non-real-time RIC, etc. Those are all open source projects, right? However, the next big challenge is how do you get the CUDU and RU to participate in the opening of the RAN, fully open source RAN. So that's kind of where one of the big areas of focus is for us. The second is on what I call AI for the network, which is kind of intriguing, and then the network for AI, which is the easy part, right? Like if you're just connecting a whole bunch of data center servers, switches, GPUs, etc. with switches, you're going to write that curve. That's not what we're talking about. We're talking about domain-specific AI for telecommunications. So what are the data sets? What are the models? How do you fine-tune? How do you learn? And we have projects under LFN called THOTH, T-H-O-T-H, that take these data sets and then obfuscate them, meaning, for privacy, you can hide the critical parameters of the data, but still train the models. That way you're not sharing things, but still learning from it. So those are kind of the most important things that are happening in the telecommunications world.
Okay, and that kind of speaks to things that Philippe Sergey was talking about this morning as our suffering keynote speaker, but that does very much touch on things, Paul Philippe, that he was talking about. So that's interesting that it's your worldview.
Yes.
Well, Arpit, thank you very much for that. A lot of food for thought in there. I almost feel like I need to go away and sit for at least as long as this session was to think about it. But thank you so much. Good news
Thank
is,
you very much. Thank you for having me.
Available online. So
bye.
watch and learn at your own leisure. Thank you so much.